Okay, so for this problem, we want to find all of the solutions on the interval 0 to 2 pi. So basically the unit circle, okay? All right, so in order to solve this, I'm going to move this cosine to be on this side. So I'll have 4 cosine cubed x, and when you move this over, it'll be a minus cosine x. And there's nothing left on this side because we moved it. Now, these both have a cosine in common. So I'm going to pull out a cosine. So notice this has 3 cosines. If I take one away, how many cosines are left? 2. So this is what's left over when you take out a cosine. Now if you take this one away, don't put 0, put a 1. The reason why is because when you distribute this back in, you should get what you started out with. So cosine times 4 cosine squared is 4 cosine cubed. If you multiply cosine times 1, you get this cosine. So you should always be able to get back what you started out with. Now from here, we're going to go ahead and solve. I'm going to set this cosine equal to 0 and solve it. And I'm going to set this equal to 0 and solve it. So for here, all I need to find is what angle is cosine equal to 0. So think about the unit circle. Where on the unit circle is cosine 0? And remember, cosine is the x value.
90 degrees?
Yep, at 90 degrees right here. That coordinate is 0, 1. So your x value is 0. So I know x can be 90 degrees. What else can it be?
270.
Exactly. Right here at 270 degrees, the coordinate is 0, negative 1. That x value is 0. So at 90 degrees and 270 degrees, your cosine is equal to 0. Now let's solve this one. You have a minus 1. I'm going to move it to the other side, making it a positive 1. And then we're going to divide both sides by 4. How do I get rid of this squared? Yep, you're going to square root it. So I'm going to square root both sides. The square root cancels out with the squared. So you are left with cosine equals, whenever you take the square root of something, you're going to have both a positive and a negative answer. What's the square root of 1? 1. And the reason why I have both a positive and a negative answer is because 1 times 1 is 1, and negative 1 times negative 1 is 1. Okay? And what's the square root of 4? 2. Because 2 times 2 is 4, and negative 2 times negative 2 is also 4. Okay? So you're going to have both a positive and negative answer when you square root it. Okay, so let's think about the unit circle again. Where is cosine equal to 1/2? At what angle? Yep, at 60 degrees. I like to think of it, it's the shorter distance. So at 60 degrees, the x value is very short compared to the square root of 3 over 2. Those were your 2 options. So your coordinate is 1/2 there, and it's also 1/2 here. What's this coordinate, or what's this angle?
300.
Yep, that's 300 degrees. And it's also negative 1/2 here. What angle is that?
120.
Yep, 120 degrees. And then angle here, it's also negative 1/2. What angle is that? 240. So those are my 4 answers. You have 60 degrees, 120 degrees, 240 degrees, and 300 degrees. So you have 6 answers total from this question. 90, 270, 60, 120, 240, and 300 degrees. 6 different angles. So we have to verify that this side is equal to this side. So I'm going to change this into terms of sines and cosines. How can we rewrite tangent?
Sine of cosine.
Yep, I can rewrite this as sine over cosine. And this can stay the same because it's already written as sine. What do I need in the denominator so that they can match?
Cosine squared.
Yep, you need a cosine squared. Because remember, whenever you're subtracting fractions, you need the same denominator. And if you put cosine squared in the denominator, you also need to put it in the numerator, okay? You can't just be big on the bottom. You have to be proportional, okay? So don't skip arm day if you're gonna do leg day. All right. So you have your fractions. The denominators are the same. So I can combine this into one fraction. So I have cosine squared x, and I have sine squared minus this. So again, since my denominators are the same, we can subtract these. So guys, this is similar to what we just did in the previous problem, okay? Let me show you the previous problem. Remember, they both had a cosine, so I pulled out a cosine. In this example, what do they both have?
Sine squared.
They both have a sine squared. So I'm gonna take out a sine squared. So I'm gonna take out sine squared. Okay, so if I take away this sine squared, I'll be left with 1. And I can easily get back what I started with if I multiply them. Here, if I take away the sine squared, I'm only left with the cosine squared. I just brought the minus sign down. And if you multiply it back in, sine squared times cosine squared is sine squared times cosine squared. Okay? So you should always be able to get back where you started. Now here, you need to recognize the identity. So guys, look at your formula sheet. Look under Pythagorean identities. What can what I'm highlighting be replaced with?
Sine squared.
Yep, this is the same thing as sine squared. So I have sine squared times sine squared over cosine squared x. Guys, we're almost at our goal. We're almost here. Do you guys recognize something?
The sine squared and cosine squared could be a tangent.
Exactly. Sine squared over cosine squared is just tangent. So this is sine squared, and what I just circled, that's just tangent squared. So you got the other side. Okay, so we want to find the exact value of cosine u and sine v. And we're given that sine u is 12 over 13 and cosine v is -4/5. And both of these angles, u and v, are in quadrant 2. So I'm just going to sketch that real quick. This is the angle in quadrant 2. I'm going to do angle u. And I'm also going to sketch angle v. They're both in quadrant 2. Now remember, you got to remember SOHCAHTOA. I'm given sine. Sine is opposite over the hypotenuse. So the 12 is your opposite, 13 is your hypotenuse. So 12 is the angle, is the side opposite from angle u, and 13 is the hypotenuse. Over here, cosine is adjacent over the hypotenuse. So this is the adjacent side and this is the hypotenuse. Your hypotenuse is always positive. Your hypotenuse is always positive. So go ahead and do Pythagorean theorem to find these missing sides. Ready, go. Okay, so if you did Pythagorean theorem, you should have gotten 5 and 3. Now remember, we are in quadrant 2. So that means this has to be a -5 because you went to the left. Okay, now we can answer the question since we found the missing sides. Cosine of angle u. Cosine of angle u is adjacent over the hypotenuse. So that's -5 over 13. Sine of angle v is opposite over hypotenuse. So that's 3/5. So now that you know that, we can do stuff finding. We could find sine of u plus v. And if you look at the formula chart, sine of u plus v, What's the formula? Is it sine of u cosine v plus cosine u sine v? Yes, perfect. Okay, so we can find that. Okay. So sine of u, they gave that to us. That's 12 over 13. Cosine of v, they gave that to us. That's negative 4/5. Cosine u, we just found that. That's negative 5 over 13. And sine v, we just found that. That's 3/5. So 12 times negative 4, that's negative 48. 13 times 5 is 65. Negative 5 and 3 is a negative 15. And 13 times 5 is 65. So this will be negative 65 is in the denominator. 8, 9, 10, 11. This is 63, negative 63. So that's your answer. Next one, this is the one that's on your paper. They have v minus u. Notice it's swapped from what's on the formula sheet, okay? So I'm gonna put this in the correct order. U is supposed to go first, not second. So I'm gonna rewrite this as cosine of, I'll put the negative u in the front and the positive v in the back. Now it's in the correct order. And I can pull out a negative. So look, I'm gonna pull out a negative. This will become u minus v, because negative times a u is this negative u, and negative times a negative v is this positive v, okay? So what you have to remember are even and odd identities. So if you look at your formula sheet, if cosine has a negative on the inside, it's still the same thing. It doesn't change anything. This is still the same thing as u minus v. This is the even and odd identity, okay? So if it's cosine or secant, it does not matter if there's a negative on the inside. Your answer is going to be the same. Now, if this was not cosine and this was sine or cosecant or tangent or cotangent, then you can still do the same formula, but at the very end, make it negative. Change the sign, okay? However, since it's cosine and you have a negative on the inside, it stays the same, okay? So we can still use this formula that's on your formula sheet. You'll get the same answer. Okay, so now that you got the y, the explanation, let's go ahead and solve it. Okay. And guys, this is the same thing as cosine of v minus u. These are the same thing. Okay, so cosine of u is negative 5 over 13. Cosine of v is negative 4/5. Sine of u, 12 over 13. And sine of v is 3/5. So this is going to be a positive 20 over 65 and 36 over 65. So this is 56 over 65. So on this question, you're supposed to be using the cofunction identities, okay? So the first problem, they're telling you that sine is 23. So here, if you use the formula on your formula sheet, this is cofunctions, a cofunction identity. The angle is 23, so this is 23 and this is 23. Do you know what pi over 2 is? 90, okay. So you can think of this as 90. So what's 90 minus 23? That's just 67. So this is your answer. You just plug the angle into the cofunction identity. Does that make sense? Okay, nice. All right, let's try this one. The angle they gave you was 3 pi over 8. So you're plugging in 3 pi over 8. Are these denominators the same? Don't they need to be the same for you to combine them? Okay, so what should I do to make the denominators the same? What should I multiply by?
1 by 8, 1 by 2.
Okay, so multiply this by 4. Wait, what did y'all say? By 8? Okay, you can do that. You do it that way, I'm gonna do it this way. if I just multiply this one by 4s, I'll have 4 pi in the numerator and 8 in the denominator. Now do they match? Okay. All right. Okay, so 4 pi minus 3 pi is just pi over 8. So that's your answer. It's just pi over 8. So again, you just plug this angle into the formula, and then you subtract them. And you guys said the way y'all wanted to make the denominators the same, which is completely fine. Let me show you guys your way. So the angle that you're plugging in is 3 pi over 8 and 3 pi over 8. And you guys said multiply this one by 8 and this one by 2. So you'll get 8 pi over 16 minus 6 pi over 16. 8 pi minus 6 pi is 2 pi over 16. And simplify. Divide the numerator by 2 and the denominator by 2. 2 divided by 2 is 1, so you're left with pi. 16 divided by 2 is 8, so you get pi over 8. Okay, so same thing. So for this problem, you need to look at the even and odd identities. So look at your formula sheet. What is this equal to? Yep, this is equal to negative tangent. And look at your formula sheet. What's that equal to?
Negative cotangent.
Yep, a negative cotangent. So negative times negative is positive. So this is just tangent x, cotangent x. And these are reciprocals. Reciprocals always equal 1. So your answer is 1. However, if you didn't know that, just change it all to sines and cosines. So tangent is sine over cosine, and cotangent is cosine over sine. Cancel, 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 you're left with 1. And the reason why I put parentheses right here is because I don't want you to think I'm subtracting them. You're still multiplying. These two are being multiplied, these two are being multiplied. Okay, so we want to simplify this. So whenever I have fractions, what do you need?
The same denominator.
The same denominator. So this one is missing a 1 minus cosine x, and this one is missing a 1 plus cosine x. Okay, so now my denominators look identical. If you do this to the denominator, you also need to do it to the top. If you put this on the bottom, you also need to put it on the top. Okay, so now that my denominators are the same, we can go ahead and combine them. So your denominator, just copy it down. It's 1 minus cosine x times 1 plus cosine x. Your numerator, you have 1 minus cosine x, and watch, this is where everyone messes up. You're going to subtract the 1, and you're going to subtract the cosine. A lot of people only subtract the first thing and they forget about subtracting the second thing. The minus sign needs to go to both things. You have to distribute the minus sign. Let's start simplifying this. A 1 minus a 1 is just 0, so those canceled out. Negative cosine and another negative cosine is negative 2 cosine. Now, your denominator. Let's multiply it. Whenever you have two factors, you can multiply them. So 1 times 1, you get 1. 1 times cosine is cosine. A negative cosine times 1 is a negative cosine. Negative cosine times cosine is negative cosine squared. And notice, positive cosine minus cosine is just 0. And here, you should recognize the identity. 1 minus cosine squared. Look at your formula sheet under Pythagorean identities. What is 1 minus cosine squared equal to? Yep, I hear y'all whispering it. Sine squared. So you have this in the numerator, and this is in the denominator. Okay. Whenever you see cosine over sine, what should you be thinking about? If you have cosine over sine? Cotangent. So let's try to get that. I'm going to write this as -2 cosine x over, I'm going to put sine twice. Since you have a squared here, you can write it twice. And so here, I have my cotangent. Whenever you're simplifying things, you don't want fractions, okay? And whenever you have sine in the denominator, how can you rewrite sine when it's in the denominator? Cosecant. So this is equal to -2, don't drop that off. When you have sine in the denominator, you can write it as cosecant, and cosine over sine, you can write it as cotangent. So this is your final answer. All right, so all you need to do to verify that this side is equal to this side, you can use the reciprocal function, the reciprocal identity. So how can you rewrite 1 over sine?
Cosecant.
Cosecant. How can you write 1 over cosecant?
Sine.
Yep, and that equals what we have. And you used reciprocal identities.